AI is changing the U.S. economy in ways that are easy to miss, because they don't arrive with a single announcement or a dramatic turning point. There is no one moment where everything suddenly looks different. Instead, the shift happens quietly, inside systems people already use every day, often without realizing that artificial intelligence is now part of the decision-making process. Most people think of AI as something futuristic, experimental, or limited to tech companies. But in reality, AI is already embedded across large parts of the U.S. economy, influencing how work is organized, how money moves, how decisions are made, and how productivity is measured. What makes this transformation unusual is not its speed, but its subtlety. To understand why this matters right now, it helps to look at how the U.S. economy actually functions. At its core, it is a network of decisions. Companies decide what to produce. Banks decide who gets credit. Employers decide who to hire, promote, or train. Governments decide how to allocate resources. For decades, these decisions were driven by human judgment, supported by basic software tools and historical data. Today, many of those decisions are being shaped, assisted, or filtered by AI systems. In hiring alone, AI tools are now commonly used to screen resumes, rank candidates, and identify patterns in employee performance. This does not mean machines are replacing managers. It means managers are increasingly relying on algorithmic recommendations before making choices. The economic impact of this is subtle but significant. When hiring decisions change, the structure of the workforce changes with them. The same pattern appears in finance. Large U.S. banks and financial institutions use AI to detect fraud, assess credit risk, and monitor transactions in real time. These systems analyze volumes of data that would be impossible for humans to process manually. As a result, capital moves differently. Risk is evaluated differently. Entire categories of transactions are approved or flagged based on patterns learned from past behavior. What's often missed here is that this does not simply make systems faster. It reshapes incentives. When AI systems prioritize certain signals over others, businesses adapt to those signals. Borrowers change behavior. Companies optimize for what algorithms reward. Over time, this influences how economic value is created and distributed. Retail is another area where AI's influence is already well established. Recommendation systems guide what products consumers see, which prices are adjusted dynamically, and how inventory is managed. In large U.S. retailers, AI forecasts demand, reduces waste, and optimizes supply chains. The customer experience may feel smoother, but behind the scenes, decision-making is becoming more automated and data-driven. This matters for the broader economy because retail is not just about shopping. It connects manufacturing, logistics, advertising, and employment. When AI reshapes retail operations, it affects entire chains of economic activity, often improving efficiency, while changing the types of jobs required to keep those systems running. In manufacturing, AI is used to monitor equipment, predict failures, and optimize production schedules. These systems do not replace factories overnight. Instead, they reduce downtime, improve consistency, and lower costs. Over time, this shifts competitive advantages. Firms that adopt these tools gain efficiency. Firms that do not may struggle to keep up. This is where most people misunderstand the situation. The economic impact of AI is not mainly about mass job replacement. It is about task redistribution. Certain tasks become automated. Others become more valuable. New roles appear around maintaining, supervising, and integrating AI systems into existing workflows. The U.S. labor market reflects this pattern. Demand is growing for skills related to data analysis, system oversight, and human-AI collaboration. At the same time, routine tasks that can be clearly defined and repeated are increasingly supported by software. This does not eliminate work, but it changes what work looks like and how productivity is measured. Productivity itself is another quiet area of transformation. AI tools help workers complete tasks faster, reduce errors, and manage information overload. In fields like marketing, legal research, and customer support, AI assists with drafting, summarizing, and categorizing information. The result is not always visible from the outside, but it alters how output is generated inside organizations. From an economic perspective, this raises important questions about measurement. Traditional productivity metrics were designed for industrial processes and office work defined by clear outputs. AI-supported work blurs these lines. When one worker produces more by using AI tools, the gain comes from both human judgment and machine assistance. Understanding this shift is an ongoing challenge for economists and policymakers. Government itself is also part of this transformation. U.S. agencies use AI for tasks such as data analysis, fraud detection, traffic management, and resource allocation. These systems are designed to improve efficiency and reduce costs, but they also introduce new layers of complexity. Decisions once made entirely by humans now pass through automated systems that must be monitored, audited, and adjusted. This leads to another often overlooked point. As AI becomes part of economic infrastructure, trust becomes a central issue. Businesses and institutions must understand how these systems work well enough to rely on them responsibly. Errors, bias, or misuse can have economic consequences that extend beyond individual companies. What's often missed here is that the U.S. economy has adapted to similar shifts before. Automation in manufacturing, the rise of computers, and the spread of the internet all reshaped economic structures over time. Each change brought efficiency gains along with disruption. AI follows this pattern, but with a key difference. It operates at the level of decision-making, not just physical processes. Because of this, its influence is harder to see and harder to regulate. AI systems do not announce themselves. They operate quietly, improving margins here, reducing costs there, adjusting outcomes incrementally. But when these small changes accumulate across sectors, the economic landscape shifts. Another important aspect is competition. Large firms often have more data, more resources, and more capacity to deploy advanced AI systems. This can reinforce existing advantages. Smaller firms may benefit from accessible tools, but they also face pressure to adapt quickly. The result is a changing balance between scale, efficiency, and innovation. At the same time, AI lowers certain barriers. Tools that once required specialized teams are becoming more widely available. This can enable new businesses, new services, and new ways of organizing work. The economic effect is not one-directional. It is a reconfiguration rather than a simple gain or loss. Toward the end of this picture, the most important insight is that AI is not acting as an external force on the U.S. economy. It is becoming part of the economy's internal logic. Decisions, incentives, and structures are being shaped from within, often without dramatic headlines. The question is no longer whether AI will affect the economy. It already does. The more relevant issue is how institutions, workers, and policymakers understand and respond to these changes in real time, using evidence rather than assumptions. When viewed this way, AI is not a distant disruption. It is a quiet, system-level shift, changing how economic decisions are made, how value is created, and how efficiency is defined. And because it happens gradually, its impact is easiest to underestimate while it is already well underway.